Welcome to Fisher Math. Let's solve this integration problem. You can solve it by substitution. Solution. Here, we're going to let u equals to 3x plus 4. And in differentiating this, we have it to be du over dx, which is equals to 3. Now, I can also make this to be, if I use the change of subject formula, I'm going to have dx equals to du over 3. Using the change of subject formula, cross multiply first, then make dx the subject to give us this. 3 times dx will give us 3dx over equals to 1 times du. So we'll make dx the subject of the formula. It's going to give us this. Now, next thing to do is to substitute these values, into the original. Here, if I say that dx all over 3x plus 4 is equivalent to, I'm going to substitute replacing it with u. So I'm going to have, for my dx, I'm going to have du over 3. I'm substituting right now. Then u, here 3x plus 4, which is u is equal to 3x plus 4, will give me 1 over u. Now, this is equivalent to, I'm going to make this to come out before the integral sign. This is the integral sign. So I'm going to have 1 over 3 integral du over u. Now, integrating the u over u, I'm going to have ln u, and this is equivalent to 1 over 3. I'm going to replace that is plus c. I'm now going to replace this u with this value 3x plus 4. So we have ln 3x plus 4 plus c. This is a solution to integral dx all over 3x plus 4. I hope this is clear. Thank you for listening. Continue. Let's solve this problem, this integral problem, and using a substitution method. Now, this can be let u equals to x plus 2. Of course, I can decide to say p equals to x plus 2. I can decide to say z is equals to x plus 2. So depending on, it does not really matter. This is all just variables. So if I differentiate this, I'm going to have du over dx equals to just 1. And you'll be wondering, how did I get the value of 1? Using the law of the formula to solve the problem of differentiation, differentiating a constant will give you 0, differentiating a x will give you just 1, because I am using the rule as axn. So if I differentiate, if this is my y, differentiate this dy over dx, I'm going to have, I'll use this to multiply this, I'm going to have an xn minus 1. So I have to differentiate this value, you use this formula. So differentiating du equals to x plus 2 will just give you 1 using this formula. That is in differentiation. Now, we'll now move on to say that let's go on and continue with this problem. Let's review this. Let's make the x the subject. So the x, therefore, the x is equals to du over 1, which is du. So now let's substitute, because we're talking about substitution method here. No, you now know this itself, in itself, integral x plus 2 raised to power minus 1 dx is the same thing as integral dx all over x plus 2, the law of indices. The law of indices, we'll just bring it down. It's raised to power minus 1. So we're using the law of indices. So now at this point, I'm going to replace this value with this. That means substitute. I'm going to substitute with respect. We're going to substitute for u. So at this point now, we have, for my dx, I only have u. So this will give me du times 1 over that. That will give me 1 over u. So at this point, I'm going to have du over u. So integration of du over u is same thing as ln u plus c. And replacing that u with x plus 2, we now have it to be ln x plus 2 plus c. This is the solution of integral x plus 2 raised to power minus 1 dx. This is the value, ln x plus 2 plus c. I hope that is clear. Please don't forget to subscribe to my channel. This is Fisher Math. Thank you for listening. Goodbye.